Hello class. I wanted to provide you with some supplemental instructions for the time value of money. We'll use this concept throughout this class, so please try and understand it now so that you will not struggle later. You can also apply these concepts to your life when calculating interest rates on loans for houses, vehicles, or other personal loans. First, let's look at some steps in calculating the time value of money. Number 1, draw a timeline. This will help you visualize the question and keep you from getting confused. Number 2, identify your key data. What is in? What is a payment, or is there a payment? What is the future value? What is the present value? What is the rate? Step 3, convert the data to the same period. Does the interest compound annually? That means it only compounds once per year. It could also compound semi-annually, quarterly, or even monthly, depending on how the problem is set up. This only applies to payment, number of periods, or the rate. If the rate is semi-annual, then you must multiply the number of periods by 2 and divide the rate by 2 to correct for semi-annual compounding. If the rate is quarterly, then you must multiply the number of periods by 4 and divide the rate by 4 to correct for quarterly compounding. If the rate is monthly, then you must multiply the number of periods by 12 and divide the rate by 12 to correct for monthly compounding, as shown on the slide here. Step 4, determine the signs. You must be careful to pay attention to the sign of the present value, future value, or payments. Remember, if there is a cash outflow, then you must use a negative sign. An example of a cash outflow is investing $100 into a savings account. That is a cash outflow to be able to save, so we would enter negative 100 into present value. If there's a cash inflow, then we use a plus sign. If we want to know how much we will get back in the future, then the sign is positive because we are getting money back. Step 5. Clear your calculator memory. This step is to ensure that there's nothing left in your calculator memory that may interfere with your calculations. Simply press second, then clear time value of money, which is listed as CLR TVM, located on the same button as future value, FV. Pressing second will access the function listed on top of that button. 6. Finally enter the data by putting in your number and the correct sign, then pressing either N, PMT, FV, PV, or I over Y. Please note, if there is not a value for one of the inputs, such as no payment, then please remember to enter a 0 for that value. Now let's look at some examples. Today, Leo Burke purchased an investment-grade gold coin for $150,000. He expects it to increase in value at a rate of 7% compounded annually for the next 5 years. How much will the coin be worth at the end of the 5th year if his calculations are correct? First, draw a timeline like the one shown on this slide. Next, identify the key data. Leo purchased the gold coin today for $150,000. So we know that is a present value, PV. He wants to know the value of the coin in 5 years, so that is the N. We also know from this that we are looking at the future value. Lastly, we know the interest rate is 7% compounded annually. We can see that we do not have to further convert the data because everything is compounded annually, and that is standard. Next, determine the signs. Leo purchased the coin for investing purposes, so this is a cash outflow. Therefore, the sign for the $150,000 present value needs to be negative. Now clear your calculator memory. Remember, it's the second clear time value of money. Lastly, enter in the information and solve for future value. As you can see here, the coin will be worth $210,383 in 5 years. Now let's look at another example. Rod just won the lottery. He wants to invest a portion of the funds to leave his inheritance and spend the rest. How much will he invest now in order to leave his heirs $1 million 30 years from now if he can earn 12% annually on his investments? Start by drawing the timeline. We want $1 million in 30 years, so that is our future value and our number of periods. The graph makes it easy to see what we are looking for, the present value amount. We have already identified the future value as 1 million and the N as 30, so we just need to add in the rate of 12% and 0 for the payments. We can see that we do not have to further convert the data because everything is compounded annually, and that is the standard. We can tell the sign for the future value is positive because Rod's heir wants to be provided with the million in the future, therefore it is a positive cash inflow. Lastly, enter the information and compute the present value. Don't forget to put a 0 in for the payment. What did you get for present value? Hopefully you got 33,377. Here we can see the value of compounding. 333,377 will grow to $1 million over 30 years. Now let's look at another example. Jody takes out a loan to buy a car for $21,000. If her monthly payment is $300 and the interest rate of the loan is 8%, how many payments must she make to pay the loan off? First, draw a timeline like the one showed on the slide. Next, identify the key data. Jody takes out the loan today, so that is a present value. Her monthly payment is $300, so that is a payment. Her interest rate is 8%, so that is the rate. We are wanting to know how many payments she must make, the end value, to get the balance of the loan to 0, which is the future value. Hopefully you notice that Jody is making the payments monthly. That means our interest is compounding monthly, and we must divide it, the 8%, by 12 to make the calculation right. Next, determine the signs. Jody is borrowing the $21,000, so this is a positive cash inflow. She's also paying out $300 a month, so that is a cash outflow. So the $300 needs to be negative. Now clear your calculator memory. Lastly, enter the information and solve for the N number of monthly payments. Please realize your answer is in months because we converted the interest to months. What answer did you get? Hopefully 95 months. Let's look at another example. You want to accumulate $3 million for your retirement in 40 years. What annual interest rate must you earn if you deposit $1,000 per year each year until retirement? First, draw a timeline like the one shown on this slide. Next, identify the key data. You want to have $3 million for retirement in 40 years, so $3 million is the future value and 40 is the N. You are depositing $1,000 per year, so that is your payment. Lastly, we are not told that you have any savings now, so your present value is 0. The question says per year, so we can tell that it is annual compounding, so there's nothing to do in this step. Next, determine the signs. You're paying out $1,000 a year, so that is a cash outflow, so the $1,000 needs to be negative. You'll receive an inflow of $3 million in 40 years, so that is a positive flow. Now clear your calculator memory. Lastly, enter in the information and solve for I over Y, your needed rate. What answer did you get? Hopefully 17%. Okay, now one last problem. Your mortgage currently has a balance of $175,000 and an interest rate of 6%. How much will you have to pay each month in order to have your home paid off in 10 years? First step, draw a timeline like the one shown on this slide. Next, identify the key data. Your mortgage has a current balance, so we know that this is a present value. The interest rate is 6%. You want your house paid off in 10 years, so 10 is the n number of periods. And your future value will be 0 because you want the mortgage paid off to 0. The question says monthly, so we know that we must multiply our n by 12. So n equals 120. We must also divide our rate of 6% by 12 for a rate of 0.5%. Next, determine the signs. You owe $175,000 on the mortgage, so we know this is a positive sign. That means we owe cash outflow. Now clear your memory. Lastly, enter in the information and solve for payment. Don't forget to put a 0 for the future value. What answer did you get? Hopefully negative 1,942. The negative sign shows we are paying out this amount per month, and we already converted the data to months, so we are good there. I hope you found this time value of money supplemental video to be helpful. If you're still having trouble, then keep reading and keep watching the videos. You may also Skype me or come into my office during office hours and we can go over more problems. I will make another video for the time value of money once I see which areas you all are struggling in based on your quiz and project scores, so please check back.